Okay, so week 23 or 24, again, I'm not sure which one we're going to do, but anyways, we're going to work with separating light. And so we can ask it what is light, and the week 24's memory work is light. So either we'll preview what light is, or they'll have that as our memory work for the day. And we ask them, what are the primary colors of paint? And so most kids are going to know that the primary colors of paint are red, yellow, and blue. And we'll ask them, what happens when you mix red and blue paint? What color does that make? And, maybe purple, what happens when you mix blue and green? What happens, like make a bluish green? What happens when you mix green and red? And do you think that is the same if we mix colors of light? So I have a green light. We can show the kids here like this. You can have them turn off. I have a blue light. So filming this in my closet. I have a blue light. Hopefully the colors turn out okay for you guys. I have a blue light, and then take that away. I have a green light, and I have a red light. So 3 different colors of light. And we're going to be doing an experiment with those lights. Okay, so we're going to have to turn off the lights. So you can ask them, what do you think? Do you think it's the same? So when we mix pigmented color, we know what to expect. And do you think that is the same with light? What will you think will happen if we mix the light? So what we're going to do is I'll show you this the way the lights are on. We're going to turn off the lights, and we're going to shine the flashlight individually on our white surface and note the color. So it's kind of just what I did. We have blue light, green light, red light. And then we're going to combine the lights. So we're going to do 2 colors at a time and see what the different combinations make. So we're going to do the red and the green light together, the green and the blue light together, and the blue and the red light together. And then we're going to turn on all 3 flashlights at the same time and observe the colors that created when the beams overlap. Then we're going to put this card in front of it. It'll make much more sense when I actually show you what we're doing and observe what happens. Then we're going to pass a shadow through it and also observe what happens. So this is really cool. It's something I didn't know, that when you mix light, it's different than pigment. So hopefully, okay, so we have, let's see, let me turn these other ones off so we're not, so we have red light here, okay, and then we had, this is blue light. So if we mix red and blue, you can ask the kids, what do you think is going to happen? They might say purple. And so, whoops, my red turned off. When I mix red and blue together, you can kind of see it more there, the contrast. So it's kind of like a magenta pink color. Okay, so sort of like purple. Okay, so there's blue. Let's mix blue, and here's my green. Let's mix blue and green together. And what do we get? So if you kind of like overlap them, you can see the individual colors. And you get like this cyan blue. It's hard to see on the camera. I wish the colors would show up better for you guys. But it's like this really pretty cyan blue. And actually the next experiment, you'll be able to see it better. And then if we mix green and red, what color? Christmas. That's what I'm thinking of. But blue and red actually make yellow, which, you cannot see it very well on this, but that middle part there is yellow, and you can see it in real life. Okay, so now what do you guys think will happen if I mix all 3 colors together? So we can orient the flashlights just kind of down like this, and we're going to be pointing them. I'll have a whiteboard for you. And yeah, dang it doesn't show up as well on the screen here. But when you mix all 3 lights together, it produces white light, which is pretty incredible. So it makes white light. You want to have like a super dark room when we're doing this. So we might have to switch classrooms just so we can use the dark rooms. But yes, you have this middle portion here is white light. So all the colors combined together is white light. And we'll talk about that here in a little bit, why exactly that is. But what's really interesting about this is if I put this, this is like a plain piece of white paper, and I'm going to put it in front of the lights, and then I'm going to observe what happens on this back side. So I had white light there, right in the middle. And then when I put this over it, it separates it back into red, green, and blue light. What's interesting, I don't know if you can see in my thing, but the blue light is on the left side in here, but it's actually on the right side in my thing here. Green is in the middle, and then red. So it's like opposite of what the order my flashlights are in. Maybe that you can see both pictures there. Okay, then we're gonna take a pencil. Let me see if I can pass this guy up. Hopefully you can see. And we're gonna pass this in front of, actually I can do it this way. If I pass it in front of, I think it looks better if we're further back, but if I pass it in front of my piece of paper, we then get these secondary colors of light. So we get those yellow light, make sure you get that, yellow light, the magenta light, and then the cyan blue light. Okay, so the shadow it casts. So when we cut the hole, use the hole, it separates it back out into the different colors of light. When we pass the shadow through, it separates it into yellow light, magenta light, and the cyan light. And then if I do it, oh, it's hard to do this one-handed, so hopefully you can see. If I make, how am I going to do this? Here we go. Good thing I have tons of crap in my closet. Okay, so there's my lights separated out. So I have my white light here in the middle, separated out on the other side. So when I do this and I create this shadow, you can't see it, again, you can't really see it on here on the screen, but you can see it in real life. So when I pass the yellow beam over it, it just blocks out the blue on the other side. When I pass the pink over it, it just blocks out the green. That's pink. And then when I pass the cyan shadow, it just blocks out the red. So take it, I wish you could see it on the screen. So here we go. There's the cyan, the pink. There we go. Maybe a little bit better there. The cyan blocks out the red shadow only. The magenta blocks out the green, and then the other one blocks out. So just kind of cool to see that. You can have the kids like put their hands in front of it, which makes kind of like a cool separation of light, and just have them kind of observe, like you can see what happens when you pass shadows in front of it. So so do kind of the separating those steps, and then you can have the kids kind of play in front of it for a minute and just, I don't know, wonder how cool that is that we can separate light out with shadows, that when they all come together, they're white light, and then, but that's made up of different lights, and they mix together to make these other colors, which when we think about mixing red and blue, it typically makes red, but mixing red and green, I wouldn't think makes yellow. But when you mix those lights, it does, and it has to do with the wavelengths. So let me turn my light on here. So I'll have these printed off for you. The visible light spectrum. Let's see if my phone will focus now. So there's different wavelengths. So this is part of our memory work, and I haven't memorized the actual memory work yet. But basically it's so amazing that, so light, radio waves, all the different rays, there we go, that go through our system, there's only a small, tiny portion that we can actually see, right? So from Ava's chart, the colored light that we are able to see is represented in this tiny little portion right here, like super, super tiny. So gamma rays are down here, X-rays are there, UV light rays, so ultraviolet, so almost violet. And then we have our visible spectrum from violet, blue, green, yellow, on. And depending on the wavelength, that's how our, depends on how we visualize that light. So these has shorter wavelength, or the same wavelength, but increased frequency. No, I'm sorry, it is shorter wavelength. And then all the way out to red, which is like these larger wavelengths. So above red is infrared, which has some healing capability. So it's funny, like either side. So infrared, this is more healing. This infrared side, X-rays, can damage tissue, and definitely gamma rays can. And then we have radio waves that are flying through the air all the time, and we don't even you know, tap into that frequency with our bodies or our eyeballs, but a radio can. So again, we can just review what happened when we mix the two colors. Red and green light make yellow light. Red and blue light make magenta. Green and blue make cyan. And when we put the cards together, it separated back out to the original color, but the two side ones were swapped, interestingly. And then we use that shadow. The shadows create were the mixtures of the colors, the yellow, magenta, and cyan. Interesting. Like, I just found this so crazy. Like, all the colors mixed together make white light. So light is a combination of all the colors in that visible spectrum, right? So when we're getting white light, it's all those colors, and each light, like I said, has a different wavelength, and when combined, our eyes perceive all that mixture as light, or excuse me, as white, because basically there's special light detecting cells in the back of our eyes called cone cells, and I can try and bring a picture of this, and those are in the back of our eye, the area of our eye called the retina, and they detect red, green, and blue light, which makes sense. We had a red, green, blue flashlight. So that's all really the colors they see, and then mixtures of those colors. So when they're stimulated equally, the brain interprets it as white. So when we see all those lights flashing on the screen equally, our brain interprets all those wavelengths together as white. If the brain sees green, the green cones get very excited, and the blue and red ones aren't so we see the light as green, which is just amazing to me. So I have a few different kind of visualizations of that. So if you just have a regular flashlight, which is regular white light, it's shining basically all levels of the spectrum on something. But if the surface of that is like a red t-shirt or a red piece of paper, our eye is going to absorb all the other colors, and our eye is just going to see the red. Here's another kind of visual of that. So black is going to absorb all the colors. Red would absorb all the colors except for red, and the red would be reflected, and that's what we would see in our eyes. It would excite the red cone cells in our eyes. And then if an object is white, it reflects all the colors of the rainbow. And so again, we see like all that color all stimulating the red, green, and blue cone cells, and it like overstimulates everything, and we see it as white light, which is just, I don't know, it just blows my mind. I think these are both just spectrum. Yeah, just two different ways to see that. So that is light spectrum. I also ordered some prisms, so I'm hoping it's a nice day, and just go outside and have the kids just play with prisms and try to make rainbows, separate that color back out from the white light that we see around us, and separate it back out into the individual colors of the rainbow. And you could have them say, talk about the different wavelengths with different colors that they see. Those should be coming in the mail. And I think basically just playing with them, like not really real structured there, but just kind of checking him out and wondering at God's glory with how he created light. That is all.